Okay, good evening. Welcome to a special
FunMath number 121.
FunMath number 121. Are you ready to have some fun?
Yes.
You don't seem super enthusiastic. Okay, you ready?
Yeah.
Okay. This is a really cool problem we found in the challenge problem section of Art of Problem Solving's Algebra book. And I want to just go through it very quickly because it's a really cool problem. It says, given that x plus 1 over y equals 4 and y plus 1 over x equals 1/4, solve for x over y. Alright?
Yep.
So note, is this a set of linear equations?
No.
Why not?
Because we've got fractions.
Got fractions, okay? But we're not trying to solve for x or y, we're trying to solve for x over y. Okay, so what's a good approach to solving this equation? What can we do?
Well, let's get rid of the fractions.
Okay, so what do you want to do?
We can multiply this one by y, and we can multiply this one by x. Let's not worry about the 1/4 here.
Okay, so when I multiply this equation here by y, I get what?
You get xy plus 1 equals 4y.
And when I multiply this equation by x, what do I get?
You get xy plus 1 equals a 4th. No, x over 4.
X over 4, very good.
But 4y is x over 4.
Well, hold on, let's not jump ahead. What do you notice about these two equations?
That they've got the same, these sides are the same, so these sides have to be equal.
Okay, so this is equal to 4y, the same thing is equal to x over 4, so this tells us that 4y equals x over 4. And how can you simplify that?
Multiply it by 4.
So what do you get?
You get 16y is x.
And what can you do now?
You can plug it back into that.
What do you mean you can plug it back into that? Oh, you're going to put x equal, you're going to put 16, okay, sorry, actually that's a good idea.
So we're
going to substitute 16y up there, so we get x over y equals 16y over y.
And cancel the y's.
Which is 16. Okay?
Yep.
Alright, so that's cool. I mean, we can just kind of plug through the algebra and solve it, but there's something else that's really neat about this problem. And I just want to go through it real quickly, okay? Because there's so much more hiding behind the scenes on this problem, and there's a really interesting reason why they didn't ask you to solve for x and y. Now, remember, when I multiplied this equation through by y, I got xy plus 1 equals 4y, right? So what I'm going to do is I'm going to eliminate a variable here, just for fun. Okay? So I'm going to move this xy over here, and I'm going to say 1 equals 4y minus xy. I'm going to say that I'm going to factor out a y, 4 minus x, and y equals 1 over 4 minus x. Okay, so I can actually solve for y. I can do elimination here. And look, I have an equation right here that has a y in it, so let's plug into that. Remember, y equals 1 over 4 minus x. So I can put 1 over 4 minus x plus 1 over x equals 1/4. Okay, now this looks horrendously complicated, right?
So we can get rid of the fractions
We can get rid of all the fractions here. I got to multiply by 4 minus x, I got to multiply by x, and I got to multiply 4. And when I do that and simplify, I get this really interesting equation. X squared minus 4x plus 16 equals 0. Now, what's different about this equation from an equation that you've seen before?
Well,
What's different? What kind of equations do we know how to solve?
linear equation.
Is this a linear equation?
Nope.
Why not?
Because it's got an x squared.
It's got an x squared in it. So one thing we did was we went to the computer, we went to Mathematica, and we made a plot of this. And this shape of this graph, when I plug in a bunch of different values of x, it looks like this. It looks like it's called a parabola. And we'll learn about parabolas later on, but you know what the Greeks knew about parabolas. So people have known about shapes like this, shapes like that for 1,000 years. But there's something very interesting about this graph, is no matter what number we plugged in, we always got something that was bigger than 0. In fact, the smallest number we got was 12 when we plugged in x equals 2. So this never equaled 0. If I picked 0 for x, I got 16. If I picked 2 for x, I got 12. If I picked 100, or well, let's not try 100. If I picked 10 for x, I got 100 minus 40, which is 60, plus 16, which is 76. I never got, not only did I never find anything where it was 0, I never found anything that was where it was negative. And it turns out this is never equal to 0. What? This is never equal to 0. So it looks like there's no solutions to this. But it turns out there is a solution to this. There's two solutions. There's x equals 2 plus 2i times the square root of 3, and x equals 2 minus 2i times the square root of 3 are the solutions to this. And what's I?
I is the square root of minus 1.
I is something called an imaginary number. So no number that we tried solved this, but some imaginary numbers solve this. So that's one thing that's really interesting. That's one thing. So not only do we not know how to solve an equation like this yet, it looked like when we tried to solve it, there was no way to solve it. And there's a different kind of number that solves this equation. Is that pretty cool?
Yeah.
That's one thing that's interesting. The second thing that's interesting is when I make a plot of this number, and I make the I-axis up here, and I make the real axis down here, and I go over 2 and up 2 times the square root of 3, I get a 60-degree angle here. So this is a really special number, 2 plus 2i times the square root of 3. I'm ignoring this one for a second. Okay? There's something really special about this number. It makes a nice 60-degree angle with the axis. So that's nice. And the last thing that's really interesting here is somehow or other I knew how to solve this equation. So there must be a way to solve this equation. We couldn't figure out how to solve it. But there must be a way to solve it because I somehow knew. And maybe I'm lying, but I'm not. Okay? So there's some cool way to solve this equation. And that's one of the things we're going to learn about. And the solution to this is an imaginary number. Is that amazing?
Yeah.
So this is why I really like this problem as an exercise at the back of this chapter, because it looks like a fairly boring problem, just plugging through a bunch of algebra and finding that x over y equals 16. But it turns out solving for x and solving for y here is really, really hard. Really hard. But it's got some super cool math in it. All right?
Yep.
Okay. Good job, sweetie. Good job.